This is the homework helper for Chapter 4, Section 9 in the 8th grade workbook, Applying the Pythagorean Theorem and its Converse. Let's go ahead and start with a couple of the story problems here. I'll do 1 and 2 with you and leave 3 and 4 to do on your own. Number 1 says the length of a rectangular swimming pool is 50 feet and its width is 20 feet. What is the length of the diagonal of the pool, rounded our answer to the nearest tenth? So we've got our rectangular swimming pool. Width is 20, length is 50, and they want us to state how long the diagonal is. Well, of course, this applies to Pythagorean theorem because once we sketch it out and we see our right angle there, we see that what's actually being formed here is a right triangle. So we are obviously finding the hypotenuse since that line is the one that's across from the right angle. If you're not seeing it because of that reason, realize that these are the two sides that make the right angle, so those have to be the legs. So this side here has to be the hypotenuse. So again, the theorem, just like we used it yesterday, says if I square these and add them up, it's going to be equivalent to the diagonal squared, or the hypotenuse squared. So I'm going to go ahead and take my 20 and 50 and square them. And add them up, which is going to change into 400 and 2500, which is going to change into 2900, which is the equivalent of my diagonal squared, or based on the formula, the hypotenuse squared. Okay, so now what I want to do, remember, the diagonal or the hypotenuse is not equivalent to c squared. Based on what we saw yesterday, that's just equivalent to c. So I've got to take my answer from c squared back to c. Well, the way we undo a square is with a square root. So now I want to go ahead and take the square root all the way across. So when I take the square root of 2900 here, the result is 53.85, and since we're rounding to the nearest tenth, that's actually going to end up being 53.9. So the length of the diagonal, the length of the hypotenuse is 53.9 feet. Remember, the hypotenuse always has to be longer than either of the legs. So if we would have gotten an answer like 46, we would have known we did something wrong because that wouldn't make it longer than both of these guys. All right, let's go and take a look at number 2. It says a map is placed on a coordinate grid. Cincinnati is at 5,4 and San Diego is located at -10, -3. How far apart is Cincinnati from San Diego on the map, rounding our answer to the nearest 10? So this is employing that distance formula that we saw today in the instruction. In case you've forgotten, the distance formula is on page 204 in your textbook. What the formula says for distance is that if I take the differences in the x values and square them, and take the differences in the y values and square them, and add those two up and take the square root, that's how I'm going to find my distance. So let's try and put this into context based on this question. Remember, with the coordinates they've given us here, the first values are my x values, the second values here are going to be my y values. It doesn't matter which one you call the 2's and which ones you call the 1's, as long as you're consistent. Usually what we say is the 1's is the first set of numbers, so this is going to be x1 and y1, and the second set of numbers is going to be the 2 set, so this is going to be x2 and y2. Again, if you want to do it the other way, as long as you're consistent, if you decide you want this to be x2, as long as this is then y2, it's going to work out just fine. Okay, so formula says I'm going to subtract the x values. So I'm going to do -10 minus 5, which is going to change into -15, and I'm going to square it. And then I'm going to take the y values and subtract those. So I'm going to do -3 minus 4, which is -7, and square that. And again, the formula says I'm going to add those up and take the square root, and that's going to give me my distance. Well, -15 squared, that's the same as -15 times -15, 225. And -7 squared, that's the same as -7 times -7, which is 49. So I'm adding up 225 and 49, and I'm taking the square root there now. And that's how I'm going to find my distance. Remember, we're talking about the distance on this map, which is on a coordinate grid, not like a miles distance. So if you're sitting there going that this answer doesn't look right in terms of miles, you're right. It's not miles. It's based on this coordinate grid that the map of these places is laid over. So I'm taking 225 and 49 and adding them up, and I get 274. So I'm going to take the square root of 274 now. The square root of 274 is going to be my solution, and that's 16.55. Since we're rounding to the nearest tenth, we're going to say 16.6, and that's just going to be units. So there's 16.6 units of difference between San Diego and Cincinnati on this map. All right, let's go ahead and scroll down and take a look at some of the questions at the bottom of the page here now. In questions 5 through 10, they're asking me to find the distance between 2 points to the nearest tenth. So this is, again, me using that exact same distance formula that we just used. It's just not in the context of a story problem. So as you can see in 5 through 10, you're going to be using that same formula for each one of these questions. So again, the formula as presented to you in your textbook, and again, that's on page 204 should you need it, says I'm going to take the difference in the x values and square it, and the difference in the y values and square it, and add them up and take the square root, and that'll tell me how far apart two things are on the coordinate plane. So let's go ahead and do that with question number 7. Remember, the first number is always an x number in an ordered pair, and the second number is always a y value. Same thing in the other set. Remember, where do the little 1s and 2s come from? That simply represents the first and the second set of numbers here. So since this is my first set of numbers here, I'm going to go ahead and fill some 1s in there. This is my second set of numbers, so I'm going to go ahead and put some 2s in there. All right, so formula says I'm going to subtract the x values. So I'm going to do 2 minus negative 6. Well, 2 minus negative 6, that's going to change into 8. And then over here it says I'm going to subtract my y values. Negative 6 minus 4, which is negative 10. And I'm going to square that one as well. And then after I square them, I'm going to add them. And then I'm going to take my square root. And that's how I'm going to get my distance. 8 squared is 64. And negative 10 squared, negative 10 times negative 10 is going to make positive 100. So this is going to be the same as 64 plus 100, or 164. And remember, that's not it. Then I got to take the square root. So I'm going to take the square root of 164, and that's going to give me my distance. So when I take the square root of 164 now, the result returned is 12.806. And because the directions say to round to the nearest tenth, that's going to be 12.8 units. Obviously, what you have going on here, when we're talking about the distances here, if we're talking about our coordinate grid, if I give you 2 points that are just next to each other like that and the same orientation, in this case they have the same y-coordinate, we could just count and say one jump. Or if they have the same x-coordinate, we could count and figure out how many jumps it is. But when the points are somehow in a diagonal relationship, remember, it's not one jump because you're going diagonally across the box. The Pythagorean theorem would show us that the 1 unit and the 1 unit, if we go through the process there, means that this distance cannot also be 1 unit. So that's why we have to have this distance formula to figure out when I go diagonally across boxes how much distance is actually being covered. If they give us 2 points with that horizontal or vertical orientation, again, same x's or same y's, just count how many jumps it is. But if they don't, which is what they're doing here, you've got to use the formula. All right, let's go ahead and take a look at the questions at the bottom here now. The questions at the bottom are asking me to tell whether the given side lengths form a right triangle. So a couple things here we need to remember. One really important thing really is that when we're talking about a right triangle, the longest side always has to represent the hypotenuse. Now, they're not really messing with your head in any of these here, but they could. If they would have given us, for instance, this first one and said 7, 25, 24, that would not be in A, B, C order, or at least an order that would resemble that. Because 25, being the biggest number in the set, we would be assured of, has to represent the hypotenuse. All right? Because it's the biggest number. So the biggest number is always C. What the other two are doesn't really matter, because remember, A and B, the other two numbers in the formula, always represent the legs, and they can be mixed up any way you want. So let's go ahead and again take a look at the one that looks nastiest, and that looks like it might be question 13, 21.6, 28.8, and 36. So remember, what the Pythagorean theorem here says is that if I square these and add them up, it should be the same as this squared. Now, there's another way you could do this. You could actually forget that this says 36 and run through the formula like we did yesterday. So square these, add them up, take the square root, and then make sure the result is the same as what 30 would put out an answer that's 36. That's a little bit more work. Square these and add them up and make sure it's the same as this will probably be less work, and you won't have to worry about taking the square root. And again, you'll use the same approach here in all of these questions at the bottom. Square the first two numbers and add them up and make sure it's the same as the last number squared. If it is, it's a right triangle. If not, it's not a right triangle. So when I take 21.6 and square it, the result is 466.56. When I take 28.8 and square it, the result is 829.44. So when I add those two together, the result is 1296. So when I take 36 and square it, I better get 1296. If I get 1296, it's a right triangle. If I get something else, it's not a right triangle. When I take 36 and square it, I get 1296. So since both of those sets that I talked about make 1296, the answer here is going to be yes. And again, you'll use that same approach in answering 11, 12, 14, 15, and 16.